Hello, today we're going to be doing lesson 10.3, solving equations with variables on both sides, mini lesson. Similar to the last two lessons, we're going to be looking at algebra concepts again. However, this time we're going to add an entirely new element. And it's kind of exciting. This really is content that would be in Algebra 1, so starting to look at it now in 7th grade gives you a preview of what you're going to be seeing a lot next year. So the first thing is we'll just go through a few quick pointers, and then we'll actually do the problems and just try them out and see the different scenarios. So first of all, move all terms with variables to one side of the equation and move all terms without variables to the other side. Essentially, 1 and 2 are very similar. That is combining like terms. Occasionally you'll have multiple variable terms on the same side. You want to get those together first and then move them to either side. So we're actually going to just kind of like draw an arrow between steps 1 and 2 because they really kind of are combined. And then we're going to solve the equation by isolating the variable, just like we've done in the past using inverse operations. So though this is new, it really utilizes many of our past skills. So let's start with example 1a. It says 4y plus 18 equals 6y. So immediately I see two different variable terms on two different sides of the equation. So in determining which one to move, I want to see which one will isolate the variable more. So if I move the 6y over, that's not going to help me because then I still have the plus 18. So instead, I'm going to move the 4y over, and because I'm looking at the operation in front of the 4y and there's nothing there, that's assumed to be addition. So my inverse operation will be subtraction. So I will subtract 4y from both sides. Seems weird because it's a variable term, but it really isn't weird at all. It's just moving the term over. So 6y minus 4y would leave us with 2y. And then my last step, just like we would normally do in a single step equation, is to undo the multiplication that's happening with the variable term. So we're going to divide by 2. That isolates y, and 18 divided by 2 is 9. So really, it's that simple. Now, obviously, the problems will get a little bit more challenging. So let's take a look at B. In B, we have 2n plus 4 equals negative 16 minus 8n. Now I have constants on both sides and variable terms on both sides. Now, what I would note here in determining what to move, and it doesn't always make a huge difference, but I notice that this 8n is being subtracted. And to avoid a negative term, I'm going to move that one over because the inverse operation here would be addition. And so now I'd be adding 8n over to both sides. It would cancel over here. I'd have 10n plus 4 is equal to negative 16. Okay, now this really just looks like a fairly standard two-step equation now that I've got my variable terms together. So my next move would be to undo this plus 4. The inverse operation then would be subtracting 4 from both sides, leaving us with 10n on the left. And on the right, a reminder that if you have a negative number and you're subtracting from it, you're going to be actually adding the two numbers, but you're going to stay in the negatives. So negative 20. So if you're negative 16, you're losing 4, you're going down to 20. My last step then is to divide both sides by the 10, which was multiplied by n. That isolates n and gives us an answer of negative 2. So those are some of the beginning basic ideas here. Okay, example 2a, we have what looks to be like a scary problem with a lot of fractions. It really isn't so bad, I promise. There's a couple different ways you could handle this. One thing that you can do is cancel the denominator. When we take a look at the three denominators we have in the original fractions here, we have a 3, a 6, and a 6. And if we then realize that the least common multiple of those two values is 6, we could actually multiply the entire equation by 6, which will eliminate any denominator that we have. And the reason that that doesn't change the value is because we're doing it to the entire equation. So that would mean we would take, Let's move this up a little bit. Let's take this entire side here and multiply by 6, and then that means we also have to take the w and multiply by 6. So if you think about this, then when we have 6w over 3, you could actually write that out, 6w over 3, if you find that helpful. Ultimately, it's going to end up being 2w, because 6 divided by 3 is 2. That would eliminate the denominator, and the w didn't go anywhere. So we'd have 2w there. Now, this 6 also gets multiplied by the negative 5w over 6. But what's going to happen there is the denominator literally is just going to cancel, and we're going to be left with minus 5w. One thing to note, don't forget that the signs don't change, so keep the sign there. And likewise with the last term, because it's 6 times 1/6, it's just going to be 1. That denominator is going to cancel. And so we would end that with just plus 1. And then don't forget on the other side, we multiplied the w by 6, so we have 6w over there. So we still have our work cut out for us in this problem. What we would have to do next is subtract the 2w minus 5w to combine the like terms on this side, which is going to give us negative 3w plus 1 equals 6w. Now, because we have the variable terms on both sides of the equation, we have to move the 3w over. Now, right now, this negative is just like a subtraction sign. That 3w is being removed. The inverse then has to be addition. So we would actually add 3w over, which would cancel this over here. We'd have 1 equals 9w. I'm sorry, I'm out of space here. And our final step would be to divide by 9. And that would leave us with the final answer. It is a fraction. That's okay. 1/9 equals w. So that's definitely probably the hardest example that you would see in this lesson. Let's keep going here and look at B. We have some decimals now, nothing to be afraid of. Same process, really. We have 2.5d plus 4 equals negative 14 plus 11.5d. Now, when comparing the two, I see that the smaller d term is over here, so I'm going to move it. Again, it may not matter, but it doesn't hurt to do that. So because there's no operation in front of it, we're going to subtract 2.5d from both sides. Cancels over here, and we're left with 4. And on the other side, we still have negative 14. And now we are left with 11.5 minus 2.5, which is 9. So plus 9d. Next, we would need to get rid of this negative 14. So the negative, again, is acting like a subtraction sign. It means the 14 is going away. So the inverse is to add 14 onto both sides. So that would give us 18 on the left is equal to, and then on the right here it canceled. And so we're just left with 9d. Finally, divide by 9. And you get an answer of d equals 2. Okay, letter C. We have several things going on here. So first of all, it says negative 4a minus a plus 16 is equal to 2a minus 5. So I see two a's on the same side. So I'm going to combine my like terms first. So if I have negative 4a minus a, one thing I want to remind you of is you could always add in a 1 there, because really that single a is a 1a, and that might help you to remember whenever you're combining these. The other thing is we have a negative minus a positive, so we're going to go into, or stay, I should say, in the negatives. So what we'll do here is we'll write in a 1. So if we have negative 4a minus 1a, that puts us at negative 5a. Because we're at negative 4 and we're losing 1 more. And then we have plus 16 equals 2a minus 5. So now I need to get my a's together. Now again, when I see that this one is negative, it's going away. So I'm going to add that one over to both sides. That would be my inverse operation. These then cancel, and I'm left with 16. On the other side, I had 2a plus 5a, which gives me 7a minus 5. So next, I would move my 5 over, which was being subtracted. So we're now going to add it, which would give me 21 equals 7a. Finally, divide by 7, and we will get a equals 3. Okay. Okay, so next in example 4, we are asked to solve the following examples and explain, and we'll get to that in a moment here. But what we're going to do first is in A, it says 3m plus 7 equals 3m minus 3. So I immediately see I have two variables on different sides, so I'm going to combine them. So it doesn't really matter which one we move over. So I'm going to subtract the 3m over here and also over here. What happens is this one will cancel, and this one will actually cancel also, which means on the left-hand side I have 7, and on the right-hand side I have negative 3. Now, I think you all know that 7 does not equal negative 3. So immediately we were going to put a slash through the equal sign because that's a false statement. And because of that result, we would say no solutions. So if you have a situation where the variables both cancel and you have a statement in the end that is false, the answer would be no solution. So the explanation is just saying that there's no solutions there. Okay, in letter B, we have 6m plus m plus 8 equals 7m plus 8. So we're going to go ahead and combine like terms first. Remember, you can put a 1 in front of the single variable. So now we have 6m plus 1m, which is 7m, plus 8 equals 7m plus 8. So now to solve, I need to get the variable terms together. So I'm going to subtract 7m from both sides. And again, you can see the variables will both cancel. So on the left-hand side, I'm left with 8. On the right-hand side, I'm left with 8. And you won't see a whole lot of this chapter, but you will in the future. When you get a true statement at the end, that means all real numbers will work as solutions. So it's the contrary to no solutions. Instead, any number would work for m, and it would still create an it would still keep the equation true. So we would say all real numbers in that event. Okay, thank you.